Okay, so the next part of 3.5 is to talk about the derivatives of the inverse trig function. So first thing I want you to do is pause the video and draw a quick sketch of each of the inverse trig functions: sine inverse, cosine inverse, and tan inverse. Okay, so here are the sketches of each of them. Remember, all that we're doing really, sine inverse really means x equals sine of y. Okay, for all three of them, that just means that what you're switching the x and y. Okay, so that's all I did with the graph. The reason that I only have from -1 to 1 is because otherwise it wouldn't be a function, remember. Okay, so this section, or the rest of the section, just talks about what's the derivative of sine inverse. So I have them written here. You can pause it right now and fill these in. Yes, you're going to just have to know them. Okay, so the 6 trig inverse functions, there are the derivatives. So 1 over the square root of 1 minus x squared. And then cosine is -1 over the square root of 1 minus x squared, so on and so forth. Okay? And then, again, these are going to come up within the product rule, the quotient rule, and the chain rule. So they're not just going to be straightforward. So I'm going to do a couple examples, and then we'll come in, we'll practice more examples on these different inverse trig functions. Okay, so once you have those written down, I'm just going to start with number 9, which is differentiate 1 over sine inverse. Okay, so if we want, we could write this, instead of using quotient rule, I could write this as sine inverse to the -1 power. Okay, so now the outside function would be the -1 power. So I would bring that down. So the derivative would be -1 times sine inverse of x to the -2 power times the derivative of sine inverse, which is 1 over the square root of 1 minus x squared. Okay, and then if I wanted to write this for the positive power, my final answer could be -1 over the square root of 1 minus x squared times sine inverse squared. If I make that power positive, I would bring it down. Okay? Next problem. X times arctangent of root x. Remember, arctangent, so this is really saying x times tan inverse of, what was the function? Root x. Okay? So that's the same thing. Arctan is the same as tan inverse. So in order to do this, I need to use the product rule. I have x and I have tan inverse of root x. Okay? So if I start, I would do the derivative of x, which is 1, okay, times tan inverse of root x plus x, the first function, times the derivative of the second. So the derivative of tan inverse is 1 over 1 plus x squared, but it's not x, it's root x. So it would be root x squared here. Okay, and then times, I have to remember to do the chain rule, times the derivative of root x, which would be 1/2 x to the -1/2. Okay, so if look back, product rule should be fine. So the derivative of x is 1 times the second function, which is tan inverse, plus the first function. Now here's where it gets tricky. So the derivative of tan inverse is 1 over 1 plus x squared, but that's really whatever is here. Whatever the quantity, whatever function is here, you're going to square that here in the formula, and then times the derivative of that. So if it's just x, you don't need the chain rule, but if it's if it's anything but x here, you're going to have times the derivative of that. Okay, and then just to make this look a little better, I could write this as tan inverse of root x, and this over here would be, how could I rewrite this? So you have x times x to the -1/2, so that would be x to the 1/2. So you could either write it as x to the 1/2 or root x in the numerator, over, you'd have the 2, and you'd have in the denominator 1 plus x, because root x squared is just x. So that's my answer. Okay? The next two problems, 11 and 12, I'm going to try to just fit here if I move this up. Okay, so cosine inverse of root 2 minus x. So the outside is the cosine inverse. So y prime. The derivative of cosine inverse is what? So that's what you're looking at first. Derivative of cosine inverse is negative 1 over the square root of 1 minus x squared. But again, it's not x, it's that whole quantity squared. So if I square that, I would get 2 minus x times the derivative of that, which would be 1/2 times 2 minus x to the negative 1/2 times the derivative of inside, which is negative 1, because I have the negative x there. Okay? So here's the rule. Negative 1 over the square root of 1 minus x squared, and then times the derivative of that quantity, which is all of this here. Okay? And then if I simplify this a little bit, I would have what? A negative times a negative would be positive, so I'd have 1 in the numerator. I'd have the square root of what? Negative 1 plus x here, guys. So it would be x minus 1. Okay. I'd have the 2 from the 1/2, and then I'd have root 2 minus x 2. Okay. So all I did was simplify inside this square root and brought this down and made it a square root. And then the last problem I have, 12, derivative of tan inverse squared. Now the outside function would be the squared. So the first thing I would do is say, bring the 2 down, leave tan inverse to the first, now times derivative of tan inverse, which is 1 over 1 plus x squared. Now that's just x here, so this is just x squared. Okay, so I could write this as 2 tan inverse of x over 1 plus x squared. That'd be my final value. Okay.